But you have to shade in the area, and then you have to find the area. These are in the correct order. Okay, so now let's see. So when we find the points of intersection, we set these equal to each other. Any idea on how to solve this equation? Any idea? We cannot solve this equation with the f's because this is not a polynomial equation.
You will substitute mu for can you substitute mu for x to the 1/4 power?
Well, yes, you can, but what we have to do is raise everything to the 4th power. So have x to the 4th equals x. We have to eliminate, this is a radical equation, and we always try to eliminate the radical when we solve radical equations. Okay, so then when I move x to the other side, I have x to the 4th minus x equals 0. Anyone would like to help us factor this? Is there anything that we can factor out? We never simplify by the variable, we never divide by the variable, but we can factor out what?
An x.
Yes, indeed. We factor out an x, and we have an x cubed minus 1. The degree is 4. Now, yes, you can solve this with the app, with a polynomial. But it's very easy. X is 0, x is 1, and the other ones are imaginary. Let's still put it in the calculator so you can see what happens when solutions are imaginary. So I'm going to do that anyway, just to show you. So let's eliminate all this. So we go to apps, and we go to polynomial finder, number 9, and this is degree 4. So move over to degree 4. That's not what I meant. Move over to degree 4. And press enter, and be careful, all coefficients have to be there, even if they're 0. The first one is 1. The next one is 0, 0. The next one is 0. The next one is negative 1. And the last one is 0. Because we have x to the 4th, no x cubed, no x cubed, no x squared, but we do have x, which has coefficient negative 1, and we don't have a free term. So when I click enter, we have to get 4 solutions because the degree is 4. So here they are. 1 that we obtained, 0 that we obtained, but these, as you see, they have I. So we don't have to worry about them. But they are there. They're imaginary. Okay. So we determine the solutions. So when x is 0, as you see, y is 0. And when x is 1, y is 1. So we do have 2 points of intersection, 0, 0, and 1, 1. Okay. So we can graph now. Y equals x is the easiest linear function to graph. And we graphed it several times before. It's right here. It bisects the first and the third quadrants. So y equals x. 0, 0 will be 1, and 1, 1 will be the other. I prepared the intercepts. And the 4th root, so y equals the 4th root of x, is very similar to y equals the square root of x. So it has the same shape. So it's this. So this is y equals the 4th root of x. And this is the tiny area that we are talking about. So let's find the area. Anyone would like to try? How do I write the area? And then we'll find it. Anyone would like to try? To get us started on the area. Yes, of course, it's a definite integer from Of course. 0 to 1. Excellent. Good. From what? Upper minus lower.
X.
Upper. Upper minus lower.
Fourth root of x.
Yes. And this time I am going to write it like this, of course. Then minus the lower.
Minus X.
That's it. Awesome. And it's done. X to 3/4 over 3/4 minus x squared over 2 from 0 to 1. Oh, I meant 5. 5/4. 1/4 plus 1. Good. So when I plug in 1, I get 4/5 because I have to flip this minus 1/2. This is easy. The least common denominator is 10. So 10, and this is 8 minus 5. So 3/10. Yes? We can check just to make sure there is no error. If you want. Okay, that's not what I meant. This is what I meant. So this is 0 to 1. Careful when you enter this function, do not enter the antiderivative. Enter the integral. X to 1/4, 0.25, and minus x. And when I hit enter, I have to get 0.3. If I don't get 0.3, something is wrong. Okay? This is the error of the calculator. All calculators have a tolerance. So it is 0.3. But not 0.3 blah 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 blah. Okay, so this is the error of the calculator. Let me know what you get with your calculators. I'm curious now. Where's my calculator? Here it is. So the software gave us whatever, but let me know what you get with your calculator. So I'm also calculating it with my calculator, my handheld calculator. So x to power 0.25, that's 1/4, and then minus x, of course dx. Yep, I get the same error. So I guess the calculator cannot do better on this function. The answer is not 0.3 blah blah blah, it's just 0.3. Okay, awesome. Did we get the idea on how to find these areas?
Can we do one more?
Yes, ab-
Complicated one?
absolutely. Yes, let's do one more. Let me see if we can find 3. Yeah, look at this. Let's look at 1 with 1, 2, 3, 4. Let's see what that means. Let's say 16.
Professor?
Yes?
I gotta join from another device, so you're gonna see me ask and answer. I gotta log off of this one.
Absolutely, we can wait if you want. I'm just going to copy the
But I'm
problem.
right now.
Okay, very good. So y equals x, y equals x cubed, x equals 0, x equals 1. Okay. Perfect. Here it is. Now in this particular situation, I'm going to start graphing x equals 0 and x equals 1, but x equals 0 is this, and x equals 1 is this. So this is done, this is done. I'm going to graph y equals x, because we already graphed it, and I know that, so this is the 1. So this is y equals x. And it hits at 1, 1, of course. When x is 1, y is 1. This is done. And now, I have to be careful with y equals x cubed. If you remember, the graph of x cubed is this. That's y equals x cubed. So when I graph y equals x cubed, then I realize that when x is 1, y is 1. So it's the same point. So here it is. This is y equals x cubed. Because the area has to touch all four. Sometimes it may be some variation, but in this case, it has to touch all four. It touches x equals 0, it cannot go beyond. It touches x equals 1, it cannot go beyond. And it's enclosed right here. A nice situation, I don't have to find points of intersection. Points of intersection are here. I don't need to calculate them. So I can go ahead and write the area. Can anyone help? Get us started with the area. Excellent. From above minus below.
X minus x cubed.
That's it. Done. X squared over 2 minus x to the 4th over 4 from 0 to 1. This is it. Luckily it's a polynomial. I don't have to plug in 0 because I will be getting only 0. So 1/2 minus 1/4. 50 cents minus a quarter is a quarter. Let's see what the calculator gives, because it's interesting now to see all sorts of glitches in here. So 9 from 0 to 1, from x minus x cubed, of course dx. And if the answer is not 0.25, then who knows? Okay, it is 0.25. Perfect. Any questions on how to find these areas enclosed by or between or among graphs?
No, ma'am.
Perfect, thank you. Final section in chapter 5. This is one of the most important ones. It deals with techniques of integration. We already know one. There are many, many, many techniques. So I should only say only one more. Not techniques, but technique. One that we already studied so far is direct. Direct. I don't have to do anything. Meaning, the integral from 0 to 4 from x dx is x squared over 2 from 0 to 4. Direct. 4 squared is 16. 16 divided by 2 is 8. When I plug in 0, I get 0. So this is the first method that we used so far. And we were going to present one more. There are many techniques of integration. They are dealt with in Calc 2. Okay? But in this class, we only look at one more. Substitution. Substitution. Before we continue, please give me any function you want. Any function. Give me a function that you can think of.
X squared plus 4.
X squared plus 4. Perfect. I would like you to give me the derivative and the differential. No, I did not lose my mind. I know I asked that last time. We reviewed it today. I need it. I need it for this. I need us to
This is 2x. And it's x cubed over 3.
we're not integrating the differential.
2x dx.
Very good. But I have to write dy. I have to write dy, and it is 2x dx. Awesome. That's it. That's the differential. Perfect. Keep this in mind. And now we will talk about the substitution for definite and for indefinite integrals, of course. I'm going to start with indefinite, and then we'll move on to definite. Okay, I'm gonna share my screen, and we go to page 434. Okay, so number 1 through 44, and then the definite later on, 45 through whatever. Allow me to choose the first one, and then you choose whatever you want. I'm going to choose 3. Number 3. The integral from, the indefinite integral from x squared minus 6 to power 7 times x dx. So you can say this is simple. Raise x squared minus 6 to the 7th power, distribute x, and go back to direct. And my answer would be, if you had said that, my answer would be absolutely not. Because it's not easy to come up with power 7. Yes, we have techniques, we have Pascal's triangle, we have combinatorics, and we can determine those coefficients. But no, we're not going to do that. It's too much work. There is no need. We're going to use a substitution. Let's look at this function. This is the function. It's the integral from f of x dx. This is our f of x. When we look at this function, what really bothers you? Which portion of this function bothers you? This is not a scientific way of looking at it, but it's the easy way to explain. What bothers you in this function?
The second power.
Of course, absolutely, that bothers me too. Because that's what bothers us, I will call it u is x squared plus 6. I'm sorry, of course, minus 6. I'm using the substitution u. You don't like u? We can use y. You don't like y? We can use w. It doesn't matter, but not x. Use any notation you like. So let's say I switch it to y. Let's say y equals x squared minus 2. I want to change this integral entirely from this integral in x in an integral with dy. It will be in y only with dy. Good. So then, I need to determine dy. I need to determine dy. This is our function. Can anyone give us dy? Anyone, please?
Does dy equals 7x?
So let's go back. When we looked at the function x squared plus 4, the dy was 2x dx. When we look at the function x squared minus 6, what can dy be? That's it. Of course. I'm glad you chose that, and that's why I chose this. So that is the dy, which is 2x dx. Now, stay with me, please pay attention, because this is very important. This piece will be replaced by what?
Y to the 7.
That's it. Stay with me, please. Excellent. But now I have this here, and I have this here. These have to go away. I have the x, I have the dx, but I'm missing a 2. That's too easy. I'm going to multiply by 2 and divide by 2. When I multiply and divide by 2, I'm not changing anything, because multiplying and divided by 2 means 1. But now I have a 1/2 in front. I cannot miss this. It has to stay. And what do I replace 2x dx by? Two x dx. What do I replace it by?
dy.
That's it. Of course, I'm going to erase it from there. It was too far away. That's why I put it again. That's it. That's it. And now, which one of these two integrals do you prefer solving? This one or this one? Number 1 or number 2?
Number 2.
Of course. The substitution made this integral into a very simple one. If the substitution does not make the integral easier, then it's not the right substitution.